All right, we're back. Let's go ahead and summary of a slope of the line. So this is a summary. Whenever you have a positive slope, the line is going to be pointing up, and also your slope is going to be positive, okay? Whenever you have a negative slope, the line is going to be going down, and you're going to have a negative in front of your slope there. Whenever you have a zero slope, that means that you have a horizontal line, and there is a 0 in the denominator, which means the slope is going to be 0. And lastly, whenever you have a slope that is undefined, you will know that you're dealing with a vertical line, which means that there's going to be a 0 in the bottom and the slope will be undefined. All right? Now, another term for slope is called the rate of change. So if you see the word slope or you see the word rate of change, you know that the rate of change is actually the same thing as slope, and so you can apply that slope formula. Remember, m equals y2 minus y1 all over x2 minus x1. Anytime you see the words rate of change, because rate of change is the exact same thing as the slope. So let's go ahead and look at a couple different applications with example 2. It says, if y represents miles traveled and x represents time in hours, the slope gives the rate of change in, okay, so remember rate of change is the same as the slope, so that's y over x, and y represents miles, so the rate of change is going to be in miles per, and they like to use per for division. X is in time. X is time. So the rate of change would be miles per time, which is in hours. So we call it miles per hour. Okay? Or miles per hour, like that. Okay, so that would be the rate of change or the units for the slope. Okay, with that said, let's talk about example 2. So it says, example 2, Justin is driving from home to his college dormitory. At 4 p.m., which is right here, that's the time, so that's the x, right? So the time, this is in hours. And then it's traveled, this is in miles. Okay, so Justin is driving from home to his college dormitory at 4 o'clock. He is 260 miles from home. At 7 o'clock, he is 455 miles from home. Graph the line that represents Justin's distance. So to do that, we just plot those 2 points, this point here, this point 2 here, and connect the dots. So it's already graphed for you here. And then we just need to find and interpret the slope of the line. Perfect. So whenever we're doing that, the first thing that we need is that slope formula. M equals y2 minus y1 all over x2 minus x1. We're going to define our terms. This is my x1, y1, x2, y2. We substitute it in. We have y2, which is 455, minus y1, which is 260, all over x2, which is 7, minus x1, which is 4. So when we subtract these two numbers, 455 minus 260, let's go ahead and figure out what that is. 455 minus 260. 5 take away 0 is 5. We need to borrow, making that a 3. This is a 1, so 15 take away 6 is 9. 3 take away 2 is 1. So this ends up being 195 all over 7 minus 4, which is 3. So now we just need to see if we can simplify this further. Does 3 evenly go into 195? Well, if you remember the rule, you can just add up the digits. So 1 plus 9 is 10, plus 5 is 15. Is 15 divisible by 3? Yes, so that means 195 is divisible by 3. Let's figure out how many times. 3 doesn't go into 1, but it does go into 19 6 times. 6 times 3 is 18. 19 take away 18 is 1. We drop this down. 5 goes into 15 5 times. So that means it's 65. So our slope is 65. All right, and so we need to find the slope and then interpret the slope. And so what this means is, what is the y over x, right? The slope is y over x, right? So it's 65, and what does y represent? Y represents the miles. And there's no number here, but there's a 1, and the x is represented by hours. So really, the slope means that he's going 65 miles per hour, or 65 miles in 1 hour. So the slope means 65 miles per hour. All right, awesome, awesome. Let's go ahead and look at the next example here. So this example says, use the graph below to estimate how far Tony will have to travel by 6:30 p.m. if his average speed stays the same. So here we have a graph and we have 2 points. If we're talking about the average speed, we are talking about the slope. So we really want to know, well, what is the distance at 6:30, which would be right here, right? This is 6 halfway through from 6 to 7. So we really need to figure out, well, what is that point right there? So first, let's go ahead and figure out what this slope is. So I'm going to go ahead and write that slope formula. M equals y2 minus y1 all over x2 minus x1. Let's go ahead and define my terms. I'll call this my x1, y1, x2, y2. Okay. Yes. So let's substitute the values in. M equals y2 is 330 minus y1 is 180 all over x2, which is 5.5 minus 3. Okay, let's go ahead and simplify this. 330 minus 180. Okay, I'm going to take that over to the side. 330 minus 180, 0. I have to borrow, making that a 2. This is going to be 5. 2 take away 1 is 1. So that's 150. And then 5.5 minus 3, line up the zeros, is 5, and 5 take away 3 would be 2. So 2.5. Okay, so we need to really simplify this slope. I think in order to simplify, we just need to divide 150 divided by 2.5, and we can do that. I'm going to go ahead and do that up here. So 150 divided by 2.5. And whenever you're dividing by a decimal, remember the one thing that you have to remember is that you can never divide by a decimal. So we have to change this, and so we move it over so that's 25, and if you move it over one place to the right, you have to move it over the decimal here over one place to the right and add a 0 there. So there we have it. Now we're going to see how many times 25 goes into 1. It doesn't. So we're going to go see how many times 25 goes into 15. It doesn't. So we're going to see how many times 25 goes into 150, which it does. And I would say that 25 goes into 100 4 times, and then it would go in an extra 2 for that 50, which would be a total of 6 times. So 6 times 5 is 30, write the 0, carry the 3. 6 times 2 is 12, plus 3 is 15. So it perfectly goes in, and then we have to drop down that 0. 25 doesn't go into 0. So it goes, 25 goes into 1,560 times. Okay, then we have to remember our units, right? The slope is the y over the x, and this is talking about the time in hours, and this is talking about miles. So the y would be the miles. So it's 60 miles over the x, which is hours. So it's 60 miles per hour. So 60 miles in 1 hour. So what we're trying to do is use this graph to estimate what will happen at 6:30. So if we know that at 5.5, which is really the same thing as 5:30, they're at 330 miles. When they get to 6:30, that is exactly 1 hour after 5:30. So that means we would just take this 330 and add 60 miles because they're going to go 60 miles in 1 hour. So we would go 330 plus that 60 miles in 1 hour and then get 390. So what does it say? Use the graph below to estimate how far Tony will have traveled by 6:30. So Tony will, if his average speed stays the same, that's talking about the slope. So the slope stays the same. This graph continues on. And so right here, that will be 6.5 plus 60, which would make it 390. So Tony, we'll say Tony will have traveled 390 miles by 6:30 p.m. All right, and there we have it. So that's it for example 2. I'll see you back in a little bit for example 3.